All right, normality has resumed. I don't know why Zoom has kicked me out twice in a row, but there we go. So, first of all, hi, Matas. Nice to meet you.
Hi, hello everyone. Thanks for inviting me. It's a cozy
Uh,
group of people here. Yeah,
Very, very grateful that you're here. So, yeah, today is a Monday, a normal Monday made special by you being here. So, thank you. The way we are doing Mondays now is we have about 15 minutes to go through our regular stuff. So, and then of course we will do introductions. I'll just wait a few minutes to see who will join us. So that'll be useful.
sure.
And then we'll have fun. I expect maybe 30 minutes for your presentation. Does that sound reasonable? And then,
Yeah, I think I was preparing for 15, but I think I will go overboard. So yeah, I guess that's pretty much where I will land at the end.
okay, yeah, that sounds perfect. And then we have tons of things to go through. Shall we just start with introductions, by the way, guys?
Sure.
Yes.
Okay, let's just go by random Zoom screen. So since I'm talking a lot, we'll start with this one. Mark Anderson, you are top left.
Oh, all right. Hello, I'm Mark. I'm an erstwhile colleague of Fred's at Southampton University. My area of interest is hypertext, and through that, obviously, text. I've been part of the Future of Text group for about 8 years now, and I'm also helping out in the work that's going on in the Future Text labs. Thanks.
Yeah, I would agree with all of that. Then it's me. I might as well introduce myself, especially to you, Matas. I have been obsessed with text for quite a long time for two reasons, as I'm sure you would agree. Number one, we use text for a lot of stuff, thinking, communicating, and so on. And there hasn't been that much investment in text tools. You know, I was doing video in the 90s where 640 by 480 was a big thing and all of that. And multimedia, they called it, and rich media. And rich media is a bit insulting to text. It's not poverty-stricken media. Anyway, so we have a just ridiculously fantastic group of people here who, in this community. You're seeing the core today, people come and go. That's it, really. So, actually, Mattis, why don't you go last in case someone else joins us?
Sure.
Fabian, the man who needs no introduction, please introduce yourself.
Hello everyone, so it is I, Fabien. I'm a prototypist, which is my excuse to say I'm not a real developer. I don't do a lot of the things related to real development, namely maintenance. I think it's too complex, to be honest, and it's my excuse also to play with gadgets like this, like the little pen to sketch in 3D, to do it in 2D. But my main interest for this group and with XR in general, with all those headsets, is because I have a bunch of notes and they are literally everywhere in my wiki, my paper notebooks, all this. So I'm thinking naively that if I had my notes literally everywhere and in space, and I could grab them, bring them with me on the plane, that would be most interesting. So that's my focus. And in terms of prototyping, I can show you something just done this weekend, just to say that it is really in space. So that's my ice skating, and now it has little lights, and I'll put a couple more there to be able to go around the rink and draw in space, but with my feet if I don't fall first on my face.
Thank you, Fabian. I'm glad you mentioned the ice skates. We went ice skating yesterday, and we just used the skates they have. And first of all, they're very painful. And secondly, the actual blades are not very long, which I find quite interesting. You know, we're tool people here. So the difference in length of a blade makes such a huge difference to what you can do. So yeah, good little example there. Andrew, you're next, and good morning.
Oh boy, it's me. Good morning. Um, I'm Andrew. I've done a lot of the WebXR development for the year one part of the project. So lots of WebXR stuff, um, specifically exploring how to read documents in a sort of unlimited space, and then learning that unlimited is actually not what we want and adding restrictions to things. Um, so it's been a very interesting year. And if you stick around, maybe you'll see some of the the stuff that we've been working on.
Absolutely. And Dini, my co-PI on the other side of the world.
Hi, I'm Dini Grigar. I'm lead PI of this project that's overseeing the symposium, the book, these meetings, as well as the XR project. So I'm at the Washington State University, Vancouver, which is located across the river from Portland. So not the big Vancouver, but the little one. I also am the director and founder of the Electronic Literature Lab. I do a lot of born digital preservation and conservation work. I've been working in text for probably 40 years, if you think about the first degree I ever had. And but I have done everything from writing straight text to doing multimedia performances, doing net art, hypertext literature, and now on to preserving all of that stuff for everybody else. And it looks like I'm maybe working, Andrew, with the British Library on the generative project. That's kind of cool. So anyway, so lots of cool things in the lab. Andrew and I have been working together now for what, 4, 5 years, 6 years. And I've known Mark forever, I think. It feels like it at the same amount of time. And then, of course, Rob, whose work I have preserved. I have his collection in my museum.
So Dini, with the British Library, does that mean more excuse to come to London, I hope?
Well, probably, because I like to go there about twice a year anyway, right?
Perfection. Carl.
Hi, my name is Carl Smink. I am a XR developer. I have a CS Masters that I got from Mississippi State University. I then went to work for the Army Corps of Engineers for 3 years, making VR software for simulations for them, and decided I wanted to go back to school and work on a PhD. And that's what I'm doing now. My research is on text entry in XR, specifically VR, which is how I got PsyOpt into this group. And I am hopefully going to make some big progress on that next semester now that I'm done with my coursework.
Brilliant. And Rob, as they say, definitely not least.
Well, it could be least. I'm Rob Swigert. I've been using text all my life, and I still use it to do writing, mostly fiction, sometimes journalism, sometimes doodlings. And I'm still trying to figure out why I'm here, in what way I can affect or help along the future of text in 3D space, unlimited speed 3D space. I think it poses some interesting challenges for writing.
Rob, there are millions of reasons why you're here, but I think you said one of the best ones right now. You have such a way with words. I've been using text almost all my life. I love that. That's pretty spot on. You'd think more people would be interested in text, but it's still a bit esoteric. So, Matas, welcome. Please introduce yourself. We have a few minutes of other things, and then we dive into presentation soon.
Yeah, so yeah, I'm Matas. I'm also guilty of the same thing. I've been using text for all my life, and I see now my daughter using that, and how she develops her brain when she is starting to read books, and it's changing so fast. Then, like till that point, it's a bit, just interesting to see how that affects the development of a child. But yeah, so I'm Matas. I'm a software developer. I studied architecture. My background, I have a master's degree in architecture. I studied in TU Delft in the Netherlands, and I switched my career to being a software developer. I'm a software engineer and the founder of Bit by Bit Dev. And so I go a bit back and forth from architecture, from 3D to programming, and then I then go into programming deeper, and I just love combining those two worlds of programming and 3D and architecture as well from time to time. But I'm not I don't develop projects. I develop software now. And that software is being used by makers, people who are interested in developing 3D applications on the web. Basically, what I do is a web platform that allows you to combine various CAD kernels, computational design kernels, and use them with popular game engines like 3GS and Babylon.js. So probably you use those as well with your WebXR experiments. And yeah, today I will just briefly introduce you to the tool. And yeah, about me, I have also like just recently started another company with my partner in the Netherlands. I lived in the Netherlands for 10 years, and then we moved back to Vilnius. I'm based now in Vilnius with my family. So we live here, but yeah, there are still relationships a bit with the Netherlands. And yeah, so we started a company where we will do more work on architecture itself, engineering and construction market. So bit by bit is a bit more generic tool that allows everyone to use it, and we will be applying it more in the context of architecture as well. So it will be interesting times. But yeah, today I will just talk mostly about bit by bit and how it works.
So you're originally from Lithuania, then?
Yes, I'm originally from Lithuania. Yeah.
Where are you now? Are you there?
In Vilnius. Yeah, I'm there. Yeah, I'm in Vilnius now.
I just looked it up on the map. It's not that far
Yeah.
away from us.
Yeah.
Yeah, that's awesome. I have friends, but I've never been. So, oh, that's lovely. Randall, good timing. We just did the introductions. Matas did a brief introduction. He will do presentation soon. Would you mind doing a brief introduction of your esteemed self?
Sure. My name is Brandel, and I work on Vision Pro, and I build the web standards for spatial computing there. So I'm proposing and designing the HTML model element, and I work on the WebXR specification along in committee with folks at Meta and Samsung and Google. And that's actually it now. Unfortunately, Mozilla and Microsoft are not part of the conversation. Just a shame. But yeah, I joined this community a couple of years ago to kind of prompt their interest in spatial computing and what to do with the space for building, putting information into space. You know, when you don't have a small pixel grid, and motivated very deeply by the idea of embodied cognition and extended mind. These ideas that having spaces that tell you what to do with them is immensely powerful in terms of being able to remind you of what you're there to do and what kind of capabilities you have. So it's a very architectural idea insofar as spaces are encoded with the specific meanings that you have there. So it's cool to hear that one of the goals for bit by bit is that. But yeah, that's me.
You didn't join the group, Randall, in the best possible way. You came as a pirate and completely changed the course of the group, which has been to our benefit.
I hijacked the group. I think that's not unreasonable to say. Yeah, that's fair.
You subtly changed our direction from flat text. You say, Matas, when Randall joined, it was a little before I finished my PhD. And I was all about this one thing, you got to be focused for your PhD. And then Randall said, have you thought about adding this dimension? And if you said it a month earlier, I would have said my head would explode. But it was fortuitous timing. So now the general feel of the future of text community is, of course, there are many types of text we can deeply care about, including pencil on paper, including digital pencil on digital paper. But in a way, we're now looking pretty much as the 3D space being the base and everything else as a useful flattening. So it's changed everything quite a lot. Jesse, I'm glad you made it in your commute today from, what was it, Bologna to Cessna? I thought Cessna was just an aircraft.
No, it's Cesena. The right pronunciation is Cesena.
Okay.
It's a very small city in Italy.
That's really cool trivia. So yes, do you mind doing a brief intro?
Okay. So my name is Jessie, and currently I'm a student in Bologna University. I study in computer science. Specifically, my major is called digital transformation management, and my interest is like kind of a mixture of how to say, like the future of text and the and also the artificial intelligence, neural network, this kind of stuff. And I met I think almost everyone, like recently from Portland, Vancouver. So yeah, I'm very happy to meet everyone again online. And today the weather is so bad in Italy. It's raining all the time, and the weather is so cold. I don't know why, because the last year is not like this, but this year maybe it's kind of weather climate change. Yeah.
Yeah, yeah, but glad to see you safe indoor with a blurry background, so that's good. Right. Yeah, I'm very happy you guys are here. So, first of all, this call is, of course, recorded. It will go up on Zoom, where it will be transcribed by Sonics.ai. I will just assign names. If there are any mistakes there, I hope to catch them. And then we put that into our record. And Mark Anderson, in a few minutes, will talk about what he's done with the record that we've had so far this year, which will be part of kind of our 15 minutes before presentations. So by way of introduction, I do have a few notes. Number one is, Brandel, you mentioned extended cognition, which is, of course, a very important part of the community. And I noticed the other day, someone was counting with their fingers. And I thought that was kind of beautifully interesting, because is that extended mind? You know, it's connected to the brain, but it is kind of outside. It's a nice border case, because we have discussed before that if you look at your watch for the time, is that really part of you, or is it an external thing? So I just thought that was amusing. Anyway, since you brought it up, Randall. Two other things. Actually today is the 56th anniversary since Doug Engelbart's demo. So I think that's really nice, Matas, that you are talking about extending our workspace today. So I think that's really beautiful. And finally, I had lunch with my mother today, which is nice. Don't get to do that very often. And I was relaxed enough that I could actually try to explain what we're doing. So I'd like to spend a minute to explain back to you guys who are doing it, what I told her. And it was very simple. It's basically, we're trying to make it possible to move units of knowledge. And the second half of that, which is a bit obvious, is until XR, we've always had someone else own our background, our top view, our desktop, whether it's the Finder on the Mac or whatever it is. So it's always been a bit difficult to provide a new environment. But what's amazing now to me is, as a designer, I can, and I think what we're doing here allows any other designers to do the same thing, basically build an entire knowledge space for people, and a knowledge space that if they don't like one, they go to another. And the final thing I'd like to tell specifically you, Matas, about that is, we're currently looking at the icon perspective of doing that, meaning anybody should be able to move like an icon on a desktop. Doesn't mean they can open what's inside the document. So that means that if you make what we call a knowledge sculpture, or a volume of knowledge, and let's say something I designed, and then maybe go something you've designed, it should be entirely open, easy, and possible to do that. But of course, if one of those little knowledge objects contains a specific 3D model or a Photoshop file or whatever it might be, it may not be openable. And I'm saying that partly as an introduction, Matas, to what we're doing, but also to highlight to all of us how absolutely ridiculously important this is, because you can't move knowledge today easily. Just look at, document incompatibilities, and look at all these things. All companies want to own the knowledge bits. So if we meet together in 10 years and we're not able to put on a headset or projector or whatever and share things, we failed. But at least now we have the opportunity to do that. So I'm very grateful for you to come in here and really help us look at more of the dimensional aspect of that. And on that note, unless anyone has any questions, I'll give the focus over to Mark Anderson for a minute or two. Okay, Mark. Yeah, you're still muted, of course. There we go.
Sorry, and of course, having just recently moved computer, it's now asking for some wretched showing justification. Oh, come on. Oh, right. I'll have to quit and reopen. I'll be back in a sec.
Okay.
Ridiculous. Okay.
Yeah, Zoom is doing all kinds of weird things with me today. But yes, robot Mark. Good point. So while we're waiting for Mark to do the restart, there's been a little discussion that's very pertinent to this. We can talk about later, just to throw out the question. What do we call the things of knowledge in space? We're currently having a discussion between map and volume, which both have their places. It should be something that would make sense everywhere when you have a headset on or when you're on your computer or whatever. So I just thought that was an interesting thing to mention to see if it sticks to the back of anybody's brain. And here's Mark again. Yeah, Mark, go ahead, please. You are sharing, but I think you might still be muted.
Apologies, I came back in muted. Can you hear me now?
Yes, yes.
Yeah, okay. Right. I'll go very quickly because possibly the meat of this can get shunted to a Wednesday meeting, but this is about the record of, I'll put you where so I'm not looking sideways at people and actually end up looking at the pictures. What I'm looking at here is that Freud very kindly made a summary of basically transcription and other information that we've collected over the last year of recorded meetings. And for instance, these are the AI generated summaries. And I looked at this and I thought, okay, here we have immediately the problem of working in long form. So the content starts on page 25 of the document. I just thought, wouldn't it be more useful if we turn this back into addressable elements of text? So he very kindly made me a plain text version of that. So I've been through, cleaned out quite a lot of typographic cruft that's come in, weird symbols and stuff that's turned up that we don't need. And then I basically imported it into a tool called Tinderbox, which I happen to be familiar with. So that effectively you've got a meeting, then I've broken out the subheadings, and I'm in the process of extracting information about those so that we can start to query the information. Like I said, so what's been our ongoing sort of summary of, for instance, agreements and disagreements? Are we still talking about the same thing? Are we talking about different? And I've just about got as far as being able to essentially, this is just HTML here, deliberately not styling it because my approach is to never put any style in this or bar the bare minimum until you know you're styling the right data. Otherwise, it's just wasted effort. But all this, for instance, at the moment is one element of information that I've got stored in this, essentially in this database. The aim is to pull out even more. So, for instance, these URLs are actually, for instance, being, if I pick another one that's got, so I'm basically finding these and extracting them and storing them so we can more usefully use the data. The reason for laying this in front of you is a couple of things that are interesting. Is it turns out as time has gone by that the prompt used to summarize from the transcription has changed. And in fairness, the transcription itself has changed. And lest we roll our eyes too much, Freud, bless him, has done an awful lot of work in the background just generating this. So the point of raising issues here is not to sort of roll my eyes and say, oh, it's missing X, but to say, going forward, what can we do usefully to our record? The couple of things that strike me immediately is the summary, the prompt for every summary that's made should be recorded. Unless it's not changed from the previous one. So then we have a record of all the prompts, which can be cross-connected to the summaries they create. If the process from transcription through to summarization changes, that similarly wants to be treated as a loggable element so that we know that, you know, we were doing the same process for a month and then we changed it for some reason, which we should write down. Again, then all this can be cross-connected. So when you start to look at the information that's actually contained in these notes, then we can actually do something more meaningful with it. And for instance, we can do some of these things, pulling out names and provide a glossary of things. Another interesting thing that came out, Fred helpfully added the glossary, which I think came out of his thesis, into the end of this. And in going through and sort of, I went through, and interestingly, because there is no it's hard to spot typos in the small box that's used for doing glossary entries and author. So there are a few things there which I've cleaned up and I can pass back to him. But it's interesting. It made me think about the fact that if I write a glossary and some of it's written in the first person, understandably given where it comes from, it doesn't make sense when viewed as a collective item. So there's something to think about there in our use of glossaries and how we state things so that it makes sense to the reader. And really, that's the gist of it. And I'm just putting it out here in case this prompts any of you to think, oh, well, wouldn't it be useful if I could find X? Or wouldn't it be useful if we were recording this extra bit of information? So at the end of the project, for the Stone Grant especially, that we can pull together stuff and we can have in a sense, for the reader of the information we provide, we can have all sorts of interesting insights across it. And I'll stop there because I don't want to detract from time we want to put into having the presentation. But I'll just ask before I stop sharing, are there any immediate questions?
I have an immediate comment.
Yep.
And that is thank you. We've been talking about doing this kind of stuff for a long time. And it's relatively easy for me to just quote unquote dump it somewhere. I'm very grateful that you are now working on making it useful so that we can start building visualizations and queries and systems and seeing what we're doing. So it's amazing grist for the mill. Thank you, Mark.
Yep. Before I forget, one other quick learning thing is always start with plain text. And save the plain text before you do anything to it, because you're only going to be adding crap that you don't need when you want to do text analysis. Lesson learned the hard way. Right, I'll stop at that point. Thanks.
Plain text for plain sailing, right? Couldn't help it. I see you have a thumbs up. That's just a thumbs up, right, Fabian? Cool. All right, Matas, go ahead. We are very ready, eager, running over time, of course, but there you go. Sorry about that. And please.
Yeah, so I'll do my best to be quick. Let's start sharing. Yep. You see me okay? Yeah, do you see the slides?
Yes.
Yeah. Okay. Perfect. Yeah. So bit by bit dev, it's the project that I will introduce today, and I tell here that it's a platform for easy programming of geometry. It's a small lie. I mean, programming geometry is never very, very easy. You probably know that quite well from your experiments. But we do, like, I do my best to sort of make that easier than it otherwise would be. And you can find bit by bit on X. I post there quite regularly, once every week, more or less. I'm not very huge user, but yeah, I try to do that. So yeah, I already introduced myself, so I'll skip that to save some time. We will talk today about what is bit by bit. I'll then go into demos just to show a little bit how it works. And I understand that I have more or less in half an hour, so maybe I'll spend a little bit more time than on some parts, but yeah, I think it will be brief. Then I'll talk why I call bit by bit a platform, why I try to think about it as a platform. Then I'll just briefly touch on this topic about CAD and text and WebXR from my personal experience. Definitely not as involved into WebXR as you guys, but I did experiment with it. I did have some first impressions on how text or how not having text is affecting the experience. And then the rest is for discussion, questions, answers, whatever you will have on your mind, I'll try to answer. So what is bit by bit? And well, it's a web platform that helps develop custom 3D experiences. And it's built in integration with game engines, and it just allows you to code geometry in a more natural way. So from architecture, I'm used to tools like Grasshopper and CAD modeling tools like Rhino, various Autodesk products where you have a lot of possibilities. But on the web, that wasn't really available when I started this project. And my goal was to just make it easier, to have CAD algorithms available to me as a developer and to build products out of that. So bit by bit was born as a platform, as a system, as a collection of components and algorithms from that sort of need, personal need, more or less even. Yeah, so bit by bit tries to provide also tools that allows you to code tailor-made designs for the era of personalized products. And by product, I just mean a design, any type of design. Nowadays, it's really, I'm sort of trying to think about humans' personal interests, and everyone has different kind of interest and different kind of need. Even if you buy a furniture, for example, like a table, it would be nice in the shop to say, yeah, I just need 155 millimeters table because that's the only piece that will fit perfectly in my kitchen. So this is the goal of BitBybit, to allow us to build these kinds of products more and more that are customized to our personal needs. So what I did is I basically built tools that help me sketch the ideas, but also help others to play around with code. And I've started with Blockly, and I thought first that I will just make a tool for kids to play around with simple geometry. You may notice also that if you open the editors of BitByBit, like in incognito mode, you don't need to create accounts or anything. You can just start using those right away. And all of the open source algorithms are just available. Basically, most of the things that BitByBit can do, you can just do it because everything is available. And that comes from the need because, like in the European Union, we don't really allow kids to, or we try to protect kids from leaving personal information all over the place. So allow those editors to be used by everyone without logins. And if people don't accept cookies, basically, I don't even know that someone is using those editors. They are quite sort of disconnected from the platform. But then, of course, if adults or parents want to make accounts, then that's, of course, possible. Then they have to agree to the terms and all kinds of things. And I then can share also that code because I can monitor that there's no bad code on the system. And yeah, so this is a little bit, I'm giving a little bit extended version of these explanations. But so on BitByBit, there are 3 types of editors. One is just to directly code TypeScript. And in any way, like we have a lot of NPM packages that you can just take and integrate in your websites where you would code JavaScript or TypeScript, whatever you prefer. But we have also on the website just ready Monaco editor to sketch your ideas, experiment really fast and get the results. Then there's Blockly. It's the tool that is similar to Scratch, quite familiar for kids that learn programming to sort of design those blocks together. Yeah, it's just basically a programming, but then by combining bricks in various ways, that is also sometimes more intuitive for people. Then there's Read, and Read is a sort of Grasshopper type programming environment. I don't know if there are architects among you, but that's quite familiar to people from parametric design space. This style of coding where you just join algorithms with wires, you sort of transmit data through those blocks to create your design. And I'll just briefly show you how those editors work today. So these are 3 editors, but basically the code base beneath those editors is all the same. And the components for graphical editors are automatically generated basically from the API of the TypeScript layer. So this is a little bit a short introduction into these editors. And yeah, I thought I will not go too much into details. Later on, I still have some slides, but I will first just try to introduce you to BitByBit Dev. And it's just also important to note that BitByBit Dev is also the web address of the platform. Here you are greeted by this parametric object that is floating, and I will just move a little bit you guys to the side. Yeah, so it's simple spiral. It sort of represents to me a sort of infinity of possibilities. And you can already play around with it here. Like you can, make it less wide, more wide, have it more dense. You can also just control how many spikes it has. So it's all parametric, and it represents a little bit what you can do with BitByBit. And of course, things like just changing colors in this reactive approach. And here you also, of course, will find the same information that you saw on the slides with those editors. What I will do is I will just go ahead immediately and I will just start Read Editor to show how it works. So what I will do is I will click the right mouse button, I will type cube here, and I will find this command from ocst.shapes. That means that I will be using Open Cascade kernel, CAD kernel, and I will drop this component, and you see that it's on the screen. I will change its size now to 3. And to make it, so parametric means, right, that you can control various kinds of your geometry through some sort of input, like a variable maybe. So I will create a number slider in the same canvas, and I will connect it to the size input. And you see now that with this slider, I can change the cube. So it's now reacting, and in that way, I created a parametric relationship between the size and the number slider. If I swap the canvas, I will enter this space, a 3D space, where I can look into this object. So these editors are great if you're still learning to code, right? You can experiment with all the algorithms that we provide. And another thing that I will do real quick is I will fillet the edges of this cube. So just for the sake of the demo, I will hide the original. This is what Fabian wants to be improved a little bit. Yeah, let's see. So now I have rounded cube. I will change its radius as well. And you will see that if I change the original size of the cube, this whole script adapts immediately and the fillet gets applied. And I can even go ahead and say that I want to also control the fillet itself. So now I will say, okay, the maximum of the slider has to be, I'm not sure if you see that well, but so the minimum is 0, maximum is 1. I will put it on 0.5 and I will connect it to the radius. And now I'm controlling the radius with this slider. And those parametric systems sort of, they interact and you have the working model. So the same approach can be extended to create many things, like phases, houses. I will show a bit more later. Here you see the same code, the same exact thing. I will just run this code. This is coded in TypeScript editor called Monaco. So here you see as well, OST, shape, solid, create, cube. And here I apply the fillet. And if I enter the swap the canvas, I enter this 3D environment where I can again look into my model. And important thing as well is that if I click on this link, I will immediately go to the documentation of TypeScript. Basically, you can then go and understand what kind of inputs you can use in both in Read Editor and in TypeScript, and as well in Blockly. So everything is sort of related. And now let's go into Blockly real quick. I'll just hit run. So here you see a 3D text. Maybe that's also interesting, is that we can create text in Blockly, but Blockly is a bit different kind of environment for coding. So here you can compose blocks and decompose them like that. So you just drag that into the input, and then you drag it again to another input. And in this way, you compose those blocks. So not anymore with wires, but more with this sort of dragging and dropping the components into their right places. So here you can, of course, change. I don't really have too many fonts that I support because the fonts are quite hard to make workable with 3D. But yeah, so here I changed the font. I can also change, of course, the text. So future of text. Let's hit run. And you see that the script executes, the camera goes to its original position, and you have the text here in the 3D scene. So other aspects, of course, are possible to code. What I want to do real quick is I want to also create the cube. So I will go to this OCT category. I will go to shapes, solid, primitives, and I will create a cube, the cube that we already saw. I will delete this component from the canvas. I will use this to to be drawn. I'll just hit run. And again, you see that the cube was created. And now if I go back, I click right mouse button on this component and I click help. Again, I go to the same TypeScript documentation about this algorithm that explains a little bit what it does, what kind of inputs there are. So this is a little bit how the system is related to each other behind the water, and how you can code it in different ways. And everyone prefers, different kinds of approaches. So here, Blockly is maybe better suited to people who want to actually learn programming at the end. Read, for example, is also quite nice for professionals because it's so reactive. You see things happen real fast. So coding ideas, it's really fine in Read as well. But like if I, have a client and I really need to code out the big application, then I just turn to TypeScript and I don't use the editors too much, maybe to sketch some ideas and experiment with the concepts. So yeah, and for kids, I think Read and Blockly are really fine to use. They just visual, reactive inputs are like easy to change, like colors. If you would go just real briefly back here to the color. Let's just here create color. You will see that component has the color picker immediately available. So it's just easier to code, if you're a child. So this is a little bit of introduction to those editors themselves. And now I wanted to show a little bit, not the cube anymore. Cubes are fun, but I mean, it's possible to create other things with bit by bit. So here I have a parametric, Fabian, if you want, just shoot your question.
Yeah,
sure.
It's not a question, it's a quick remark that I'm very happy to see some of the comment in the chat that basically are saying that it's beautiful and it makes sense in our context, because Matthias, I lied a little bit to you. I said everybody would get it, but I was a little bit afraid it was remote from text. But obviously from the kind of response, people do understand the connection that text are within space. The spatial state needs to be shaped too. So just, it's perfect. It makes sense in our context. So I'm happy already. Please go on.
Yes, sure.
Oh, no, sorry. I was just going to say, now that we're going to this next step, and thank you for Fabian, that was great. Brandel has asked a question here in the chat that this may now be a good time to address before we go on to more details. He's asking what the guts are, if it's basically CGAL or a headless Houdini, etc.
Yeah, I mean, it's kind of inside baseball detail of how you build a computational geometry application, whether you're using Seagull or whatever else. But I'm interested. You mentioned open source algorithms, so
so I will get to the open source algorithms part a little bit, but basically, so on GitHub I have a monorepo where you can take headless, indeed. So headless algorithms and use those. I can share the link later to the monorepo of the bit dev. So those so editors themselves, they are the heads and the headless things in Read that's also, I will address that in the topics where I will be talking why I call bit by bit a platform. So basically that's where I will explain a little bit how to tap into those components. Basically, just NPM packages are available to people to use. So the OCT kernel that I integrate is available there. I hope I understood the question. Is that?
no. So if it's all JavaScript based, everything actually running client side, then that
Yes,
it rules out a lot of.
Yeah, it's on client side. Indeed, there's no cloud involved in this. So web workers all the way and WASM. So WebAssembly, that's how it works.
Cool. Yeah, I look forward to more detail. Thanks.
Sure. So this is an example of small pavilion for bikes. That's the model that loads also 3D scanned bikes, my wife as well, and it's also parametric. So here's a bit longer script. You will see that I have a lot of components here. But I can also control, for example, things like, so maybe I just need a bike shed for, oh yeah, not this slider. Let's see, this one. So if I want to create a bike shed for 3 bikes, now it will recompute. And I have now a bike shed for 3 bikes with just smaller amount of entities, a different kind of geometry. And if I want to go real crazy to 14 bikes, maybe that's also possible. So geometry recomputes, and I don't need to, as a designer, I don't need to spend time remodeling this architectural piece or small architectural piece to like suit this new need of the user. If you, for example, sell products like these bike sheds, you just configure it to suit the client needs. And this is then a bit bigger script. Here you will see already a bit of this platform approach. So the same code that I had here, I exported to Runner. This is Fabian is a bit familiar now with runners, but so this code was exported to Babylon.js runner, and then via StackBlitz, it was exposed as an application to run in 3D. And I've built a small UI here on StackBlitz where I can do, again, control these things. And I can switch between the kid's bike and the adult's bike here. Yeah, Fabian, sure.
Yeah, just a quick remark also, like to connect that slider, because also everything was explained briefly about being with runners and no build that you can also imagine it as a VR slider. Namely, you pinch on that slider, you're in space in 3D, and the model responds to that. It's on the web page in 2D, of course, changing the 3D model, but you can imagine this being inside an immersive environment.
Yeah. Yeah, I will try to also show some videos of WebXR experiences that I've built where I did use some graphical user interface elements. But yeah, indeed, what Fabian says is correct. Like, so those inputs, they can be provided to the scripts from many different sources, be it WebXR graphical user interfaces or like these, in this case, HTML inputs. So yeah, and in the context of the editor, it was just this number slider, right, that was connected to it. So here you see that, yeah, it's a bit technical, but get runner input value, I can just get it sort of from different context as well and use it in the script. So this is a little bit to showcase that those scripts that people create, so if they don't know how to code, it is still possible to sort of export them to JavaScript and still run it. That JavaScript itself is not very beautiful maybe, but at least technically that's feasible to export those scripts to JavaScript. So I'll go into another slide. This is, again, a different kind of design. So this is a table. In the epicenter of it, there's a 3D model of Palm. And for example, Babylon.js really supports this technology called Gaussian splatting. It's quite a new thing on the web. Well, not new anymore in the web standards, but this is really the plant that I scanned with my mobile phone. AI just generated 3D model. And this model as well is parametric. So like how high the table is, how many legs I want to have in this model, I can control. So now it's just recomputed to have a bit fewer of those elements. Also, if you just increase the height of the table like this, you will see that model just recomputes. It takes sometimes a bit more time. So now the table is higher. And I don't need to remodel anything. I mean, as a designer, you're free to decide which parameters you want to allow your users to change, which are important or which should remain static. So in this case, the Palm remains static, but the table is adapting constantly. Another example, this is just to express a little bit this approach where code just helps. For example, so this is a conceptual architectural piece. It's not meant to be built or whatever. But imagine, you would need to design this 3D model by hand. Like there are so many small details here, like those windows on the top. And if something changes, you would need to really remodel everything manually, and that would take ages. So that's where parametric design also helps you. You design a system, and if something changes, you change maybe some variable indeed, and the model will recompute and will readapt. This is just making a lot of sense in certain types of designs. Not all, definitely not all, but sometimes manual approach doesn't really work anymore. So computers and algorithms, you see that this script isn't too big, right? I mean, it's quite large, it's long, but it's not crazy big. Like it's still, you could go through those components, read it out. You will find some JSON editors here integrated. You can also, by the way, write code in these components. So you can go here and just hit this TypeScript component and do some coding here. Also provide inputs even to these components. So this is a bit fun if you're a developer to play around, and many things are possible. So I went through some examples, and I will just go back a little bit to the slides to explain a little bit this aspect of the platform. Okay, so for some piece of technology to be called a platform, to myself, I have this idea that various levels of that stack should be available to users. So users should be able to tap into what is basically available. For example, if you just want to use Open Cascade geometry kernel in your applications, you should be able to do that. If you want to use, for example, this whole CAD system with Three.js, it should be possible. If you want to use it with Babylon.js game engine, it should also be possible. So for all of these situations, I've developed node packages. So you can pick and choose how you combine your stack, where you use it. And if you go to npmjs.com, you go to bit by bit dev, search for components, you will find, I mean, this is not crazy popular library still, but it's getting there. And so for example, the core, you can plug it and use it either with Three.js or with Babylon.js, and you will see two dependents. So these two libraries that we expose as well, they are meant for those game engines. I don't have more like integrations, but potentially, Play Canvas could be added here. And then those CAD algorithms would be available to those game engines as well. Basically, with in the context of Three.js, the layer, which is called bit-by-bit dev Three.js, is just providing some helper functions to create meshes out of geometry that CAD kernels create. So this is how it functions. It's a bit hard to explain, but basically, you see here in this diagram that all those NPM packages are just stacked on top of each other, and each layer is depending on the core layers. And at the end, you have to just choose your flavor. Is it Babylon.js? Is it Three.js? And you can go and use it with those game engines. Yeah, Fabien, sure.
Yeah, quick remark also, especially for here in our context, quite a few people are relying on Three.js. And today, for example, I added a mesh generated by Open Cascade, the kernel, through bit-by-bit dev. And that mesh, I was then able to traverse it and then change wireframe, color, the things people would normally do with a Three.js object 3D. So again, that's kind of the connection for people who are not familiar with this entire stack, but they're familiar with Three.js. As long as they got their mesh, their object 3D, they can do the usual things they want to do, like it's been generated, it's been manipulated to be generated the right way, and then you're back in well-known territories.
Yeah. So also, I'm not a PhD in mathematics, right? So I'm not developing geometry kernels is not what I do. What I do is I take the kernels that someone else, those PhDs developed, and I just try to make them more accessible. I do develop some algorithms on top to make them a bit easier to use, right? So I do dig into the APIs of those kernels. I do use them as a professional, but I also try to simplify a little, So for example, it is possible in bit by bit to create open cascade geometry and then create, for example, Babel-NG mesh, convert that into the manifold and use manifold algorithms against that mesh. So this is a little bit technical, but without these layers that allow you to traverse the data between those geometry kernels, it's really, it's really hard to use those as a singletons, right? So it would be a bit of a wasteful time. And I will just go a little bit to finish this technical part. To just explain a little bit what that CAD kernel means is there's like two universes, right? Just to sort of, one is Platonic universe, or that's how I try to conceptualize it, where CAD kernels do their things. They compute geometry. They, for example, you can say, I want to cut one sphere from another sphere, right? But during that process, you don't really need to draw anything on the screen. You just do that somewhere in the background in that CAD kernel. It computes that whole result. And then at some point, when you're finished with all your manipulations of geometry, you say in Three.js, okay, kernel, give me that mesh, give me that object, give me that sphere, give me the result of this operation, whatever it is. Is it maybe, sometimes it's a line, right? Maybe you're cutting, I don't know, surface with another surface, then it will be a curve, or if you will be doing Boolean difference operations on solids, it will be another solid probably. So at some point you're finished with all those manipulations, and then tell Babel-NGS or Three.js, draw me that object on the screen, and that's when you get it basically visible. So in the context of WebXR, that means that computations can happen. The Meta Quest Pro or something can do the computations in the background. And then at some point, you just draw it and make it visible on the screen. So this is a little bit how to conceptualize it. Yep, sure.
Yeah, so when I think of the Platonic universe, I think of the solids that he lays out in his, philosophy, right, in his dialogues.
Yes.
But when I think about the virtual world, and this is what I've been trying to get through the heads of my students, is that we're not bound by the Platonic shapes, right? We can do other things.
Yep.
So I guess my question to you, I see that you've got a half moon, which is not a Platonic shape to the imagination. So I'm guessing that just watching what you're talking about, we can do a whole lot more than be bound by the squares and the triangles.
Yes.
Okay.
Yeah, so if you would maybe notice that projects in bit by bit, they are quite more complex. So basically, the moment you begin using the algorithms of Open Cascade, for example, that whole approach of thinking changes. So it's indeed less about solids and then operations on the solids. It's more about thinking, okay, maybe I have a really curve, for example, in 3 dimensions, and then I want to create a surface between two curved curves, and that is called loft operation, for example. So
Plato
those
couldn't
lofts,
get to curves without, the way Plato could get to curves is through many, 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 many squares, right?
Definitely it's possible, right? So, but indeed, it's a bit hard to define mathematically as well. So, yeah, it's interesting how that plays out. Yeah.
May I ask you one more thing? There was a
Sure.
colleague of mine when I did a postdoc at the University of Plymouth in England, and one of my colleagues in the postdoc program, who lives in London, by the way, and is an architect. He was a 4D architect. He was designing 4-dimensional spaces, which I thought was really quite wonderful. I've got a couple of his architectural drawings as work of art in my house. But I'm just wondering if that can also be something that can be envisioned in this space, because I want what I tried to do all semester was get my students to quit thinking in normal space, so spatial terms, right? To get out of
Yeah.
that. But I felt like I was beating my head against the wall.
Yeah, well, WebXR is interesting because I mean, it depends what's that fourth dimension is. And I know that's why I mentioned I'm not a mathematician, but I know in mathematics, dimension is just whatever you can have as many as you want, and time and various kinds of things indeed. And I think when WebXR, this becomes maybe even more apparent, like text, for example. I mean, maybe it's not a dimension per se, but that layer of information, it is needed. Like it is basically, as a user, you do expect some sort of feedback from, as a human being, first of all. Like as a machine, maybe you don't, but as a human being, you do need some sort of textual feedback from, so even very simple stuff, like if error happened, like, do I see it? Do I understand it? Can I respond to it? What should I do with it? So this is very, it's relevant. I saw that quote. I have it here even somewhere. Yeah, on your webpage, we are going to make machines intelligent, but what are you going to do for people? So this really triggered me. It's actually, in fact, with WebXR, even more relevant. That, I mean, there's a lot of hype about everything and AI, but then, is it still understandable? How to understand it? How to make it readable and readable also for human being, right? Just but about four dimensions, definitely. I mean, interesting. The game engines, they allow, first of all, a lot more than CAD programs. So, for example, in Rhino, for example, or whatever you use from Autodesk, you have buttons, you have 3D models, but usually you don't have this possibility to interact with 3D objects. You cannot really, I don't know, click on the text or something. Fabien, you have a question, sure.
Quick remark is it's indeed the slider again that you showed in 2D on the page. So we can think of doing it in 3D. We move the thing around, but it can be time also. I mean, there are constraints. You need a big machine. Let's say if you want to make a complex shape in real time, that's probably not even possible. But it can be also motion. Like there is a famous game, I forgot the name, where time was bound by your motion. So if you were static, you were not to move, no time wouldn't flow. And if you were to move fast, time would flow fast. So we can also imagine this kind of thing here, like some of the parameters for the design of the shapes are based on your motion or time, or basically, again, because it's parametric, all those things can become dimension to change the shapes.
Yeah, and interactive. I mean, you can touch those objects, right? You can do many things. They can react to each other. So this is just a small thing to just think about bit by bit. I know it's not very easy to think about it as a system. It has many component parts and everything, but basically just these technologies, that are being packaged, and then you can create 3D models, 3D websites or web shops, whatever you create on the web, and probably even more. I can imagine, depends how you use it. With that, I just wanted to go into this text in WebXR. I already mentioned a little that this triggered me. But it's more about, personal experience that I had using WebXR, and I have few projects that also use bit by bit. So here, for example, this is a small house project that I was working on, and you see here that I'm interacting with the house, like it sort of changes its shape for a time being to be responsive. Then it takes time to recompute. But you see that there's still this UI floating in there. I mean, I didn't really have had time to experiment too much with it. But like, even though that interaction, with natural interaction, you can click on the point, you can move it around, you can play with it. But at some point, it's still, if you want precision, you do need some inputs to define your model more precisely, like maybe you will enter the number or something. I have here another example. So I'm not sure on Twitter, this is a more recent one where on MetaQuest Pro, I just opened the editor and I have one component that sort of allows me to enter the WebXR space and see the result in WebXR. So here I'm coding on the browser of MetaQuest, and I'm changing this geometry in WebXR. I'm seeing the thickness change. It's really interesting experiment. Although I must say, having the device itself is, not yet maybe powerful. Maybe I have to work on performance as well a bit more. But there are so many possibilities for designers. Where you still can experience and change those designs in one single space. So here, this graphical color picker is in WebXR, for example, but the rest of the script is in the browser. So this was really fun to code, more like an experiment. And then last one, I have here 3D vase. So this is also just allowing to change its parameters, adapt it a little, see the change in. Sometimes the results are crazy, but it's all algorithmic. So you can change how many subdivisions it has, how many. Yes, in this case, you see that I'm also allowed to change this sort of shape by doing these gumball transformations. But I activated this mode from the graphical user interface. So that's where the text and what you can do with your model, it does. It's still needed. It's really without it, it's really hard to have more complex applications, more intuitive applications. And with that, I think I went through most of. Last thing, just because I mentioned that I recently started this new company, and we will still be doing. I want to just show a bigger piece of maybe more practical one that we developed as a demo. And here we have small house. So this is bit by bit is controlling the shape of the house. And I'm also able to say, maybe the roof should be higher. Maybe the house should be wider. And you see that it recomputes, and based on your size of the house, right? The interior also changes. You see that now the table has only 4 chairs, but if I say that the house should be bigger, wider, you see that it sort of adapts, the interior space adapts, so and everything changes. And please don't pay any attention to the price. It's really just for demo purposes. We don't sell those. Just we will be building mostly the configurators like this. But these kinds of systems where you gamify architecture or design, it's really allowing to create non-standard, non-static things, which gives a lot of opportunities. And I will end with that. If you have any questions, let me know.
I just before question then and before opening. So first of all, thanks, and I saw a lot of claps in the chat. I'll extend the demo just a bit, I'll just try to share the screen. It'll be quick, so don't worry for all the questions and discussions. Let me know if you can see. Can you see my screen?
Yes.
Okay, so I made a little heart a long time ago, which looks a bit like ice cream. It's to also show that, when you're not used to it, it's not Blender, it's not this kind of things, and it can be difficult. So I used OpenSCAD a bit, so that's for 3D printing at home. I've done a couple of other versions, but it wasn't easy. So that one part also to try to maybe time a bit the enthusiasm, but what I showed also a bit in the Slack is, and that's mostly thanks, of course, to Matthias versus the work, and then even during the last few days. So that's the usual demo you've seen in XR a couple of times, where there are icons of different 3D objects, and that was the demo of the symposium. But now there is a kind of shelf, and what's exciting is exactly what Matthias was saying before, that the shelf itself, basically, there were a bunch of parameters, and you could add as many lines as you want. You could change the size of it. So I'll try, of course, live demo, so not going to work, but just in case.
Fingers crossed.
Well, so it did work. Now I have a total one. The whole point is that here I symbolize the room outside through this, which is also parametric, is if the room size change, the size of the scale of the shelf change. And then it's not just like changing the scale, it's the number of curves and all this. So basically, thanks to Matthias' work, it's not beautiful, as all of you know, that's not really my thing, but it works. Like it is arguably functional already. And that's, yeah, thanks to Runner, thanks to all the different works being done there. So it doesn't make me a designer or an architect, far from it. I'm very excited though, because I've been trying to do this, like I was showing with OpenSCAD and previous attempt with Manifold before for a while now, like years. And now, thanks to the platform, basically, it's coming together. So I'm super excited. I want to thank you again, because yeah, it's there. And
Fabian,
again,
it's beautiful. Huh? It's beautiful. Also,
we were also discussing with this, like Brendel was giving some example just like 2 weeks ago, I want to say. And I was like, yes, that's exactly the kind of thing I'm into. But to me, it has to remain parametric so that the different dimension and the usage do adapt for it. So yeah, now it's already partly in. That works in WebXR. I mean, I'm really hyped. So I want to thank you again.
No problem. I'm really happy that it worked out as well. Yeah, we chatted quite a bit last week.
Yes.
Really
Sorry
nice.
for this, but if you kept on giving great advice, so I couldn't stop.
Definitely.
Yeah, fantastic.
It's yeah, that's really nice work, Matas. I am curious about a couple of things. First is, so I have my in my note here is what I want is diegetic hyperparameters. So the first part of that is the diegesis, this idea that you have the ability to portray things in the world that represent the parameters that you have. You had the color picker in there. You had the dots that allowed you to apply it to run a lathe. Was that in bit by bit, or was that
no? So that was already Babel and
or...
JS. Yeah. So
right.
Babel and JS or 3GS have the gumballs, or basically I subscribe to these as events indeed, and then change the geometry based on that.
That makes sense. And do you have, so one of the like you were saying, like one of the problems with geometry resolution is that it's super slow. If you want to have the high fidelity Boolean operations or whatever else, if you want to be able to do it, inset skeleton to be able to manage a chamfer surface or whatever. So do you have any mechanism for being able to, something that I do sometimes with this is I'll draw intermediate feedback that's representative of the guide rails. You can update one or more splines at a closer to real time for the purposes of going like, here's where we'll get to, and then kind of leave it to an outer process to resolve. Do you have any capacity to have that kind of two-step process between like, here's what sort of control speed level kind of feedback, and then it'll resolve into those other things?
Yeah, so it's twofold. Twofold answer, I guess, to the same problem. So what you saw with the house, for example, house fell back to sort of linear model, basically just wireframe, and it was basically a separate algorithm for this real-time speed. And then when you're finished dragging, on drag end, you just trigger the final result to recompute the final model with all the intricacies. And you can even have a third, of course, button, to really go and texture, apply textures, and super realism. But like what my experience with WebXR, so you have really limited compute power. These CAD algorithms are quite expensive. It can take a bit long to recompute. The more complex the model, the more longer it takes. I mean, it's not crashing, right? But I mean, yeah, it is taking its time. And but both Open Cascade, like if you have so Open Cascade, for example, it has built-in capability to mesh the B-rep representation. So that kernel works with boundary representation, and then you can choose the meshing precision. So how many triangles you want to create out of the description, and it solves it correctly to the sort of closed mesh. But like if you use less triangles, it will just perform better. And what I noticed is, so yes, the computations in the CAD kernels, they take longer, but mostly the performance issues begin to surface because the mesh itself is just too expensive for GPU, basically, and that's where the heat comes from and everything. So it's a bit, I really want to try PCVR. I must say, I didn't. I really would like to see how because on the browser, on my Apple, I have Max 1 or something, performs like I can do a lot of things. I know that, like for example, I don't have that much RAM available, but still, even though it may be taking a bit longer, maybe for the algorithms to compute, it's still fine. And also, I try to avoid, for example, when I use Open Cascade, I try to avoid Boolean operations as much as I can. I always try to define my final shape just from faces, right? So like I am trying to just switch my head from using Boolean operations into more like, how can I define the boundary of the object? Even if it's quite complicated, sometimes there are smart ways to go about it. And then algorithms can sometimes be really, really faster. So there are tricks to use to get that performance out of the system to be faster or slower.
Yeah, but it's interesting that you think that the majority of the issue is actually pushing the geo through the GPU for render time. Because another opportunity you might have for something that's sort of somewhere between PCVR and what you've got today is to be able to offload some of your compute to a connected machine via WebSockets. So you have the ability to just throw that workload. And if there's anything that's computationally more expensive, and like
Good
some
one.
skeletal decompositions and stuff like that might actually fall into that bucket. But it could be an architecture that could let you do a little more there. In practice, I don't know how much you've done with real-time 3D outside of this kind of sort of generally sort of CAD-ish stuff, but in practice, real-time graphics leans on stuff like normal maps and low poly mesh decomposition, so that people have the ability to get high poly things. Like you would not put polygon chamfers on something if it's something that you don't super need for the actual silhouette, and even then people will use LOD and stuff like that. So it may be worthwhile to take a look at what or if or where it might be possible to jam things into normal BICs and other things like that. That's a whole different sort of set of responsibilities where you need to then deal with UVing and other things like that. But sometimes it's worth it. But it's super interesting work. I don't know do you know Trimble Creator? A friend of
Trimble.
mine.
No,
Yeah.
I know Trimble, but I'm not in contact with the creators. Yeah.
I helped a friend build he did most of it. I just pointed him in the right direction for some of it. The system, it used to be called Matter Machine and then Materia, and then it was acquired by Trimble, and so now it's the computational geometry core in SketchUp.
I know. Okay, yes. Yeah, I think on LinkedIn I have him for Materia. He sent me the links. Yeah, I remember.
Yeah, cool. Yeah, Tom Koliskens is real fun. But it's super interesting to see because it was precisely that sort of configurator generation system that I think is really important. But yeah, like those responsivenesses, as you kind of intimate with your ArchViz one, is that like that's absolutely essential for people to be able to build these kinds of expressive objects of the kind as well that Dini was mentioning, like things that kind of can be responsive enough to reflect specific sort of textual components and have those pieces of information. Have you ever heard of I'll stop talking soon, I promise. Have you ever heard of Chernoff faces?
Chernoff.
Yes.
No, I don't think so.
So it was this insight that if you personify multivariate data sets by, for example, saying that the proportional size of eyes and the size of the mouth and the shape of the mouth is something that conveys data, then we have a significantly higher level of legibility and capacity for being able to process it. I think it was Kirsch who said that if you get like three-dimensional abstract blocks, of the kind that are on IQ tests for determining chirality, like is this a stereoisomer of that kind of thing. You just put a head on it, then it makes it almost trivial for the human mind to process. So there's some really interesting ways of using data transposition, particularly if it ends up being somewhat anthropomorphized, that are really, really valuable for this. So it's out of scope, obviously, to turn a general ArchViz kind of thing into something for a humanoid configurator, but I think it's really interesting to recognize that some dimensions are easier to read than others, and if you can jam complicated data into simple channels, then you can give people a lot more literacy in terms of what they get out of it. But I'll yield the floor.
Thanks. I have it now on my Wikipedia, so I'll be looking into that.
Quick, easy technical remark is indeed, if you don't want to buy a desktop computer for PCVR, CloudXR, assuming you have a good connection, works quite well. Like you just store the browser, you have SteamVR, and that's it. Whatever headset you have, that will do, and you normally don't have to rebuild anything. That being said, I think like some of the question Brendel were hinting at before was, and I posted the link before, the inventing on principle from Brett Victor is how do you get fast feedback? And I think especially for us here, it's interesting in the sense that arguably we don't really know what we're doing because hopefully it's genuinely new. So it means we have a whole, like what you show us, give us a whole landscape to explore, virtual landscape of both the inside, the indoor architecture, let's say, and outdoor architecture. And Dini was highlighting how it doesn't have to be like the usual Cartesian one. We can be hyperbolic, we can have other dimensions. Like there is so much to explore, which makes it even more important that the feedback is, I want to say efficient, which probably implies fast and like making the right decision, like what is costly to compute, what can we have like as widgets to like just explore extremely efficiently again, because how do we get there? Maybe also how do we do the history of changes? Because when you were showing the in AR some of the change to the vase, I was thinking, oh, maybe this one is nice, but maybe I want to highlight on the slider that I've already explored this with that parameter, and that was this result. So I want to now that I have a series of design that have been available to me, how that landscape has been explored so far, and where are still like unknowns to explore. So I think that specific part of once you have those new possibilities, this new landscape, how do you navigate through it efficiently? I think that's one of the most interesting questions.
Maybe real quick before the next question, I may respond. Like, so some stuff, of course, is left to the programmer of the application. So, for example, some things like, okay, if you want to log the history of changes, for example, well, you can pick those, right? Every time some inputs changed, maybe you just put that somewhere in the memory and retrieve it later. Maybe you want to save the design indeed that. Now with this, for example, what I notice, if there are many parameters that configure the object, it's sometimes indeed just impossible to remember what was the configuration. So you have to somehow save it or whatnot to the precise setup. But and in terms of speed, again, it's like a bit the points maybe are fastest, right, to represent things, but curves are fast, surfaces become a bit slower. The more triangles there are, the slower it gets. And but yeah, it's a bit of also trial and error, what works best for particular applications sometimes, maybe. That's also a thing.
Sorry, it's funny how in the end, like computational complexity partly binds our ability to create. Like how costly and thus how slow it's going to be generating is it prevents us to going from some corners of that landscape and allows us to go faster in others.
And
So I have a
that
question that
part,
take us
yeah,
in a
sorry.
slightly different, slightly different direction. I was really prompted by sort of Denis' reflection about, wanting these things available in a space. And I was watching when you were working, I think it was on the REIT interface, and unsurprisingly, you were looking around for the right input box. And I was thinking, it's one of the things we already sort of see in this group is the different perspectives, say, between a programmer, a graphic designer, and someone who's a sort of literary person. They're all looking at text, but through very, very different lenses. The text is the point of collision. So, for instance, and I'll preface this by saying I don't think this is your job to do, but the question came into my mind watching it is, for instance, does things like REIT allow you to have more meaningfully descriptive controls? In other words, use this slider if you want to make this box bigger, because depending on which axis you come into this interface, that might be actually the only way you understand how to use it. You may not understand the full sort of constructional part of it. You know what you want to do, and you just want to know which lever to wiggle. And as I say, I mean, the tools are growing all the time. So it's me asking the question isn't to say that this isn't here, but it's more that we're probably getting to the part where we can consider how that aspect of annotation, of description, can get built in, because we have to do all these other things before we can even conceive about having this meeting point. But I do think it's really interesting thinking about some of those perspectives. So there's the computational perspective, there's the visual aesthetic perspective. So it's the architect, the graphic designer who understands a sort of intuitive sense of space or how things look. There's the person to whom, say, textual objects especially are more in the inner meaning, the meaning within the text itself. And the fact it's in this rendered font or that is almost immaterial, because the meaning lies within it. But they might still want to do transformations on that. And therefore need the handles to do that. But anyway, I leave that reflection there.
No, but you're completely right. So basically, as a developer, sometimes you forget that you have to explain something to a user, and that's exactly what I also meant a little bit with the WebXR. The text is essential, and also I sometimes leave out indeed things that or forget that should be explained. And in read context, for example, so what you described basically is a feature that is still missing, a comment, right? A comment that I could add next to the component and say, okay, this is, variable that will control a certain thing. So definitely it's on the list, by the way. But yeah.
There's also an interesting playback in that, is thinking about once you have that sort of mapping, be able to say, well, if you're playing with sort of this aspect of the shape, all these things that light up, these are all the things that feed into it, because that's interesting too. It provides a sort of quite subtle learning that steps outside having to have a formal understanding of all the geometry or the programming platform understanding. It's just another thought I'd throw in. But thank you. I found this really interesting. Thanks very much.
No, thank you for comments. Yeah.
Yeah, I think you're still up.
Quickly on Mark's point, my little adventure down that path has been funny, because I'm a developer first, and I tried first to use the API and use the code. And honestly, initially it was too hard for a couple of reasons. First, that's still new to me. Parametric design, I've been excited by it. I have books on generative design. Quite a few different books on the topic, some related to architecture itself, but this on generative design which is it's beautiful. I do recommend it, by the way. It's gorgeous, but I haven't really taken the time to do it. So I love the idea, but it's been like I'm not sure it didn't really click to the point of actually doing it. But like, oh, I'm a coder, I'm going to use the code. I didn't manage because I think the way to think about it did not click. And I used Blockly initially because that's what's welcoming for beginners. It was a bit trickier still. Then I used the graph basically way. And for me, for discovery, that was much easier, much more efficient. But then I wanted to go back to code, and then I started to wonder, like, how does that work? So the representation, the bounded representation itself, and then Open Cascade, the kernel itself. So going from all the way up to all the way down, and then finally back to code, because that's what I work with, and that's what gives me also the most freedom. But the point is, I had to do a couple of back and forth at the different level based on my then understanding. So the tools themselves and the ability to discover how they work and the underlying concept behind it, it's not a linear adventure. It's not something like, oh, I'm reading the doc, I implement, and boom, that's it. It's more like back and forth through the different tools with the different representation.
I walk the same path still, so don't worry, right? So yeah, the only thing I just want to, so that you would still walk it, right? But at least a little bit easier than. So I'm trying to sort of help out, but basically at some moment I also begin missing something, and then I start reading, and yeah, it's still a lot to. I mean, Open Cascade, for example, I don't expose everything that is possible. I expose a part of it, but there's just so much in it that I mean, it's really so these things they develop it for 25 years already. I think maybe if I'm not mistaken. There is a lot to unpack there. Like, I mean, not sure if I will ever unpack everything, but indeed, there's many things to do. And also, maybe just I remembered, so this BREP representation, you can save it. So, for example, you can put on the screen, you can put low res, right, mesh, but you could save it to a boundary representation file called step. And you can open it in FreeCAD or in other CAD software and work on it manually then, in Fusion of Autodesk. So this makes it possible to do that. I'm supporting, like, I don't support fully the step, but I mean, most of the things that you can imagine, I think that would work out. But importing, for example, big assemblies from Fusion, I know that some engineers wanted that. They didn't succeed, sadly. I don't have full support for, really advanced things. So I will work on it further. Maybe at some point I will, but basically it's like possible to say that, even if you lack resources on the browser, you could think of a way to get it into professional CAD system to finish it off, for example, or maybe you parametrically address part of your design and the other part is just GLTF that is loaded or something. And in those ways, you can begin building the app. Yeah.
Thank you. Brandel, is it a quick one?
It starts quick. You mentioned GLTF. Also, USD. Make sure that you look at USD and how to support it. It's if you haven't tried it in Vision Pro,
I would imagine. Look, I basically GLTF and USD. So I would imagine that Babylon GS does that. Like, so the
not really, not yet. No. So if you want to generate a USD right now, the best thing to do is actually use the WASM build of USD lib. There is a relatively unsophisticated exporter that Mr. Dupe has written for 3JS, but there are better things, and it's worth looking into exactly what USD is. Not just a file format; it's a workflow mechanism that Adobe and Autodesk, and Autodesk, both are signatory members. We're going to start something called the Web Working Group soon. I will be the chair, I believe, and it will be useful for folks to be able to actually think of USD as more of an interchange system for being able to work across things. and have things like non-destructive collaborative workflows that are probably going to be worth your while to take a look at. So yeah,
definitely. Yeah, thanks for pointing me to directions. Yeah. Oh.
That actually helps me with my comment question issue. First of all, Matas, thank you. This is exactly what we need, a deep dive into something that's central to what we do, but we're not all experts on, to say the least, though we do have at least 3 serious experts in the room in addition to you. So here's the thing. I'm going to Brussels on Thursday, and the idea for that was just to have a chat on icons, on the visual design, just for Fabian and me to talk about the very superficial stuff, not project stuff, not serious stuff, not coding stuff, right? And so that means I have been fully engaged with my brain. I'm basically an artist by birth and trade. Keynote things, sketching even on paper, having fun. And it turns out very quickly, and I'm sure you all come to the same conclusion, that the icons are, of course, important, but it's how they are together that really matters. So that's why it's so wonderful today to see what you're showing, because just like we have AI, generative AI, as an opportunity now for doing visualizations and all kinds of things, which represents a very specific set of tools. This represents also, at least for me, a new and very specific way of looking at things. So first of all, there's a question I want to throw out that we started today with, but then also, Matas, as we try to understand this world of generative and parameterized, sorry, it's a tough word, design, I hope we won't just see it today. I hope you will be back. You've opened some skulls today, most certainly mine. I don't know how much came into my head, other than seriously large amounts of inspiration. So if you want a community where you can come in and there's some back and forth dialogue, I think this is definitely one of those communities. So that was the big thank you.
Yeah, thank you for for greeting me and inviting as well. And I can imagine, definitely I can imagine that we will stay in touch with Fabian, maybe on more immediate term. But if there's something that we will think is maybe interesting to you guys, I'm definitely interested to join in. And I must say as well, indeed, in this world where there's so much stuff happening that sometimes important things get overlooked a little, and I don't really remember when I read the website. So I opened your website and I went through the text, just concentrated like I was reading the book, and it sort of it inspired a little to understand that there are people who still remember that we are human and important things are still important, right? It didn't change because all of the great stuff. And indeed, generative AI, I'm also thinking, because I did the experiment, I throw my complete API definition to Gemini, I think, was it? I asked, okay, code with this API, a sword. Like, I mean, it did understand that it had to create sort of cross, but it was out of boxes, so it wasn't very great at the moment. But I mean, it did do something. Who knows how it will play out? I think it's interesting, of course, but still, this sort of designer precision is still relevant at the moment, at least.
Yes. And then there's a question. Let's see how long there is an interest in this question, but especially what you've shown us today, I think it'd be worth spending a few minutes on trying to figure out what we call a collection of knowledge in this new XR world. We've been toying with, as you heard in the beginning, primarily volume or map. I like volume. I think Rob introduced the notion of volume because a book is a volume, but it's also space. So that's beautiful. The only problem I have with it is if you go between different media, like if you're on a normal 2D screen and you're working with your knowledge things, to call that a volume, and when you go, that doesn't fit. So that's why I'm wondering maybe map, right? You have a 2D thing, you go into your 3D world and back and forth. So yes, Fabian, I see your hand, but Matas, with all your dimensional geometrical thinking, what kind of language do you think fits for moving knowledge connections around?
Me not being a native speaker, I will definitely try to avoid the question somehow in a smart way. Yeah, volume is interesting one. Like I know that drives on the computer were at least called volumes as well. It's also a bit dimensional. It's interesting. I don't know, but I am not gonna go and vote on that one. I will keep it a bit silent for myself. Yeah.
Oh, political. All right, Fabian. Let's see.
So volume, of course, but why? It's because we don't need to worry about the keeping the older version, let's say the 2D screen. It's already there, people are already familiar with it. So that's not really my worry, that people would wonder how they would be able to use that with the old way, let's say the flattened way of the 2D screen. What worries me again is, that's what I was trying to express earlier, is that we use the old way with the new way, or rather that we forget how to actually genuinely use the new medium. That's what is actually worrying me, because the old one will really use a certain way. It doesn't mean we should keep on using the old medium, the old way, and not try novel ways within it. But I think if we keep on stay flat in VR, in 3D, in XR, it's not worth it. Like it just, it's so that's why the push, let's say, the insistence on without necessarily leaving behind the old medium, at the very least, not bringing so much weight and baggage that we forget why we put those effort into trying something new.
So agreeing with every single word you said, I disagree with the conclusion, which is great fun for discussion. So naming is, of course, really, really important. My concern with volume is that, as I said in my little intro bit, what we're working on here is to move knowledge around. The most immediate is to move it in front of us. So we have like a spatial hypertext or a knowledge graph or memory palace, whatever the need is, whatever the size is, that's what we're talking about. A lot of it will be 2D because it's simple. Hopefully, we'll get more and more 3D because it's important and it's richer, no question about that. But we will also really need to access this from flat displays, even 10, 20, 30, 40 years in the future. There will sometimes be flat displays. So what I'm saying is, my perspective is, the map is not the territory, is no longer true when it's digital. In a computer game, we say, what map shall we play next? The word does actually mean that now, right? I'm not saying it's the correct uses, but that's what people say. Are there any new maps for Call of Duty or whatever? They are called maps. They're not called levels, they're not called places, they're called maps. So what would be a natural language for someone who's working on a 2D display of knowledge stuff on a laptop or a computer that's connected to XR and back and forth? I'm not saying map necessarily is the winner, but I'm saying that volume isn't necessarily so easy. So I don't know. What does everyone think? Dini, please.
Well, I think about what Bob Horn's doing with his maps, right? I mean, he showed me his collection, which is pretty extensive, and he's been doing this visualization with maps for what, 40 plus years. That's not what we're doing. And I think what I really liked about Mates's final presentation was the house with the person moving around in it. When I think of the VR, XR environments, I think of movement as much as I do of depth, right? So I'm not thinking of width and height. I'm thinking of depth and movement. And then also touch. We feel like we're touching things even though we're not. So when I'm playing Beat Saber, for example, I feel like I'm holding the Beat Sabers, not controllers, and I feel like I'm hitting the boxes because of the responsiveness we get, right? The interactivity, the sound helps to give this sense of haptic experience. It's those things, and that has nothing to do with, I mean, there's really not a term for this, and I think it's really hard. That maps does not make sense to me either. So I think the problem is, like in everything that we try to define or describe, is that there's nothing in the current world to make sense of it. And we give these terms as kind of provisionary terms with the idea that in 5 years, 10 years, 100 years, somebody's going to come back and say something better about it. People in the Middle Ages didn't call themselves living in the Middle Ages. The people in the Renaissance used the term medieval, right? So whatever we come up with is not going to be what we end up with. But I think we can probably come up with something that reflects depth and this kind of other kind of sensory experiences. Because even those boxes that are square have the potential of interactivity, and we want to touch them, right? Anything that's 3D, we want to manipulate. Just one more thing is anytime I show the beach ball in my museum to anybody, the first thing I want to do is throw it. In fact, anything that people do in a virtual environment is to throw it. There's something human about wanting to throw things in a VR environment. Why? I don't know. I'm sure there's a study on it, right? But anyway, just saying. Thanks.
That's really beautiful, Dani. Just comment before Mark. Maybe we should spend a little bit of time. This is basically marketing, right? We're marketing ideas. And I do agree very, very much that we don't want to use stuck ideas. I mean, the word map, the etymology of that is fascinating, has changed many times, but it may very well have run its course, right? Volume is very exciting. I really like that one. But when Dini highlighted, I was thinking not so much time, but interactivity. But we got to find some sort of a term that we can throw around with our friends and just say, oh, when you're working on, I mean, one of them was knowledge sculpture, right? It's a bit long-winded. But yeah, we got to think of something. Yeah, Mark, sorry.
Yeah, well, very quickly on the latter, perhaps the thing is to not rush to try and define things too early and let the terms actually come out from use, because sometimes I think we unwittingly rush to define things when we don't need to. We know what they are. And then we get name recognition. So the reason I put my hand up was I was thinking about Dini's point about Bob Horn's maps. So it's really interesting doing some deconstruction of these. One of the things it really reminded me is that the sort of narrow gap he'd been pushed through, because Bob's been thinking about sort of hypertextual design for a long time, and yet the maps he produced are effectively made in Illustrator and are completely flat artifacts. Because I deconstructed some and I had to actually use text recognition to get the text out of the image to build it back into something. And that was a useful reminder, because the sort of framework of things we've just been looking at today is another good provocation. Is to say, right, well, we're now giving ourselves a sort of constructional process that allows us to hook back. So if we only think to construct these things like these visualizations in a way that things like individual pieces of text or individual blocks that are, even if it's a fixed image, but it attaches, say, to a particular idea, that it's addressable in the form of, okay, it can be used to paint onto the front of this object, or it can be used to be the descriptive text nested within this object, that you might discover if you wanted to read about it. Just that thought. Thanks. Bye.
Really briefly, before you ramble, I'm so sorry, but Mark, it's kind of important, because in my software author and Matas, my software is commercial, separate from this. However, it serves as an exemplar of how to connect. That's why we're trying to make all these open JSON and all these fun things to go between. I have a tab called map. So I need to be able to label that in a way where someone puts on their headset and they connect with what's in this map, which is basically knowledge graph, right? That naming is consistent. I may very well need to say, this is a map, and by the way, you put on your headset, it becomes blah, blah. So I'm not saying it has to be the same word, in the same way that this defined concepts in my software export becomes a glossary. Nothing wrong with that. But because we're starting now on year 2, it's worth, with your input, because you're literally making it 3D in the fantastic sense to go through it. So at least having a better chat about it, Mark, is all I'm saying. Brandel, please.
I immediately hypocritical on this point of the naming, because on the one hand, I'm like, I don't think we need to decide right now, but on the other hand, we urgently actually do. At least, I mentioned I'm proposing this HTML model element, and model is an awful name, but because we already use it in the web. I don't know how much of a web developer you are, but like the document object model, the DOM is a place where it's already there. So it's sort of joining that sort of canon of um, horrifically overused words like set and map. Both also just have dozens of equally important, equally separate definitions. Um, and so, yeah, there will be some interesting sort of collisions from what ends up being kind of laid down, because um, model or whatever else somebody gets to call it will be what a 3D model is referred to on the internet as here and after. And it'll be interesting to see whether we have other sort of intrinsically spatial kind of things that we can use, a terminology we can use to characterize the other things that are not strictly models, but are also 3D or scenes or volumes or spaces or whatever else. And likewise for all of the subordinate ideas. Like initially there was people wanted to have model get and set camera, and I put a kibosh on that, and so it's now going to be entity transform. But those are both terrible names. Entity and model and transform, these are like they mean everything, so they mean almost nothing. And then environment map is another part of the API. These are just like if you're deep into the details of those things enough, then they can sort of seem descriptive, but they almost at the top level mean almost exactly the same thing. So it's an interesting one to sort of chew on for what must we do in order to get the work done versus what troubles are we setting ourselves up for the decades and centuries to come, when hopefully some of this technology is still to be used.
That was perfect. It makes me put in the chat here view spec, which sounds a bit ridiculous, but it is a specification for what an environment should be. Now, maybe to help us with this discussion, I now have three things in the map, and I'm so excited to tell you guys. I can't believe I managed to wait till the last 6 minutes of our call today, but there's three things. One is a defined concept. That is a bit of text. You do control-click define, then you write a bit about what it is. That's it. And that can then be connected to other things. Don't worry, Matas, I'm not going to go into all the details. It's just the point. Anyway, so you have defined concepts. You also have just notes, just text on this thing. Does nothing. If you export your glossary, it's not included. It's just a bit of text. Turned out to be very useful, as I've texted to a few of you recently. Then finally now, and this is all Fabienne's fault, I have something called linked, right? So I looked into all kinds of things, connections, all kinds of fancy words, but Fabienne and his environment used links, and that makes sense. Three types of links. Link to a heading in the document, link to a local document, which can be the same kind of a map. So that means you can now nest maps, and then of course a web link. So the reason I'm bringing these three items up in the conversation, of course, there can be other images, 3D items, all of that stuff, right? We are talking about a knowledge space, right? I'm working on a flattened knowledge space. Together, we're working on richly dimensional knowledge spaces, right? I'm wondering if those specific things will maybe spur something in someone's brain. And no, we're not going to call it second brain. So, Matas, this is the kind of thing we discuss here. Normally on Mondays, we
It's
go.
perfect. No, the naming is the hardest thing in software engineering and beyond, I can imagine. So, yeah, it's and the thing is that you have to then live with those choices. I get why, sometimes you have to spend time to think about that.
Yeah, and I agree with you so much, and that's why I was so grateful to talk to my mother today. It was she's 89, and she doesn't use a computer, she doesn't text, she uses a phone, clever woman, lives in a different world. But to just talk about, mom or grandma, as we call her now, in the future, you do stuff on a laptop, put on the headset, future meaning, a few months from now, then you have all these bits related to your work on the wall or in the room. of knowledge that you can move around to better understand things. Some of them are simple text, some of them are very clever. And then you can give it to someone else. The gift to someone else is obviously crucial for an environment. So when you talk to somebody outside of our community, what do you call it? I call it knowledge objects, the little things. But what are the collections of? Right? Mark.
Just very quickly, thinking on your thing about links. I mean, I think it boils down to, web links are, in a sense, obviously web links because they're just going somewhere else and they're playing in the web world. Within one's own tool, links originally, because it was all text going back, essentially you had a granularity. You'd have a link between essentially two objects, two nodes, for want of a better word. You can call them what you will, nodes, objects, whatever. And then you might, but you could, in a sense, have an anchor within that. So back in the days of text, that means that this word was the actual anchor, as opposed to this whole piece of text being the link. And then I think that model actually plays. Yeah. Oh, right. Is that Brandel off? I saw a hand. Anyway, I saw somebody else. So I think that is the sort of granularity, and you don't need to look too much beyond it. Within an individual tool, one may have an interaction in the way that you make or the way that you perceive links, but they're not different types of links. In a sense, they're all links, and really, the bit you play with is a degree of granularity within your object model as to where the link is actually sort of stored or its address lies. And then obviously within one's individual tool, one may visualize it in a particular way, but they're all links under the hood.
Yeah, I think that's quite important, Mark. And we are running out of time. So I don't mind having different names, but I think it's for different uses of the same thing. I don't mind that at all. There's nothing wrong with, in my little world, it's a map, and then you put on your headset and suddenly it's a volume. Nothing wrong with that as long as the user knows. I just think every once in a while we need to have that little discussion. And Matas, as I said earlier, I will say it again. Actually, I'll say it in a different way. I started using Photoshop in the 90s, right? And it was a new kind of thing, and I was young enough then that my brain understood this new kind of thing. What you're doing now is, in the most lovely way, obvious, but the fact that you're actually doing it is not obvious, right? So it is so, I'm so grateful that you come in here and you're doing a real thing, which is, I don't know, we can find so many names to it, computational space, or relative space, all of these wonderful things. So I'm very, very grateful. I hope we can continue the discussion, and hope that when we see you again, whenever that is, by the way, feel free to drop in any Monday, same time. If you have 5 minutes, an hour, 2 hours, it really doesn't matter. People come and go as they can. And then maybe in the future, some of us will have more intelligent questions, not only Brandel and Fabian, who are deep into this. So that's it, really.
Sure. No, thank you. Thanks a lot for inviting. And I enjoyed the discussion. You guys are doing interesting things, definitely. And I'm glad to address at least maybe some of what you're doing. So I'm really looking forward to seeing also some results from Fabian. You have some really nice developers here. And ideas, and that's two things that usually produce really nice and interesting things. So just wish you creativity, and definitely I'll keep in mind that I can jump by and be welcomed by this community. So super nice.
You're so welcome. And in the last few seconds, so much when I visualize when I see your system, not visualize, but literally see it, with the nodes and graph, of course, there are other things that do this, DaVinci and so on, to see it and the way you've done it with basically, the way you can provide APIs in and out for the outputs and inputs and so on. In this knowledge map volume wall thing, one of the dreams we have in the community is to have these little knowledge objects be plain text or an entire LLM, right? So it can interrogate the room of knowledge you have and say, hang on, I am an LLM representing this and that. What you have over there is rubbish, right? That's something we have, but to have what you're doing, to have an object in the room or a collection of objects that can understand the room and then can change a visualization based on that. Holy moly, right? I don't know what that means at all. But I do think it'll be wonderful to think along these lines. And again, I thank you.
Thanks.
So on that note, everyone, see you all when we can. And yeah, brilliant. This will go up on the YouTubes, and then there will be the Sonics, and then we will do we're experimenting with new prompts for the summaries and keyword extraction and all of that good stuff. So Matas, you will obviously get access to all of this. It'll be in our journal. All right, bye for now.
Thanks
Bye.
again. Take care. Bye-bye.